Hard clipping is a type of distortion effect where there are three regions of operation we're interested in relative to the amplitude of our input signal. When the amplitude of the input signal is relatively low, we'll be operating in a region without distortion, such that the amplitude of our output signal is equal to the amplitude of our input signal for that time sample. As the amplitude of our input signal increases, it's possible for us to go outside of this region of operation. Consider the portions of our signal that have positive amplitude. For hard clipping, if the amplitude of the input signal increases above some maximum threshold, those peaks are going to get clipped off, such that our output amplitude is equal to that maximum threshold no matter how high the amplitude of our input signal goes. Similarly, consider the portions of our signal that have negative amplitude. For hard clipping, if the portions of our input signal have a peak that drops below some negative threshold, they're going to get clipped off. Hard clipping is sometimes also called digital clipping because it occurs in a couple different cases when you're just working with digital signals. If we were to try and save a digital signal to a fixed point file, a 16-bit or 24-bit WAV file, the signal we're working with has an amplitude that goes above 1 or drops below -1, it's going to get clipped off when we save it in a file. This is a type of hard clipping. Another case is if we were to try and convert a digital signal to an analog signal. The D to A converter has a maximum and minimum level that can allow, and it will pass the signal through as long as it fits within this region of operation. So let's take a look at how we can use conditional statements in MATLAB to create our own hard clipping effect. Let's go through the process now in MATLAB of writing our own function to perform hard clipping. I'm going to make use of this script we created previously for testing the different types of distortion. The first thing I'll do is open up a new M file. This is where we'll write the commands to perform our function. The first thing I'll do is put in the keyword at the top of the script to indicate that this is a special type of file, a function file. It has input and output variables or arguments. In square brackets, I'm going to put that we're going to create an output signal that gets assigned the result of this function called hard clip with input arguments, including the input signal that's going to be processed, and also a second argument. This one, I'm going to give the variable the name of threshold. This is our level that we can set as a user for using the function to say, if our signal goes above this threshold, we're going to clip it off. So now I'll save the file. It has to have the same name as we have in our script. Now all that's left to do is implement the commands to perform the hard clipping. I'm going to copy over some of the code that we created previously and just modify it. So before, we're working on an infinite clipper. In this case, we're going to change it. So that's going to perform hard clipping. We'll still use a loop to go sample by sample through our signal so we can change the amplitude. So the first thing that will happen is we'll go through and check a conditional statement to see, is the amplitude of our input signal greater than this threshold? This is the maximum level that we'll allow. If this is true, then our output is equal to the threshold. So no matter how high our input signal goes above this threshold, our output signal will still have this same value. Next, we need to set up that there are actually three different conditions or operating regions. So I'm going to add an extra else-if statement here to test whether our input signal at the current time sample is less than or equal to the negative threshold. So this is the case when our input signal has a negative value. We want to check, is it less than this threshold? If that's the case, this part is true, set the output to equal negative thresh. I'm going to make sure I have it spelled correctly there. Great. Finally, we'll add in a third condition. This is when neither of those things are true, we want to be in a region of operation where there's no distortion happening. So in this case, we'll just have our output signal equal to the amplitude of our input signal for the current time sample. That's all we need to set up our hard clipping effect. We'll go back over to our distortion test script and make sure that it works correctly. I'm going to comment out this previous function. In this case, we'll create an output signal by calling this hard clipping function, passing it the input signal. We also need to pass in a threshold. So here, I'm going to create a new variable. We'll say 0.75. This is the maximum and also minimum level that our signal can reach. If it goes above this level, it gets clipped off. We should be able to see this when we plot the output signal. So I'll run the script. We can see we have the two signals, the input in blue and the output in red. And it's true, if the input signal goes above 0.75, our output signal gets clipped off and it stays at this level. Similarly, if the input signal drops below negative 0.75, then our output signal gets clipped off. This way, if we like, we can change the level of this threshold, which will change the level of the hard clipping. So now when we process the signal, we can see that we've clipped it off at a different level of 0.5. So those are some steps that we can use to write our own function in MATLAB to perform hard clipping.